Hello everybody, today is Monday, October 30th. So today you have homework 6 too. Okay everybody? And this Friday you have homework 7 due and quiz 4. So like I said before, because we postponed the homework and quiz due date, that's why the following month you're going to be very busy, right? So on a week, look at the schedule. This week you have 2 homework and 1 quiz. And then next week, next Wednesday, you have exam 3. Okay, everybody? So I need you to study hard and yes, we're going to be very busy the remaining 1 month, right? Okay, so let's continue on session 5.3. So 5.3, we were talking about the problem that you're given a piecewise function and they want you to find the values a and b such that the function is continuous. And then part B, they want you to find the values a and b such that the function is differentiable. Do you still remember this problem from last time? So we continue. Let's look at example 6. All right. Okay, so we have 2 p's, right? And you see exponential function and polynomial. And this one, are you able to look at the screen from TED Live? Yes. The second piece formula. Do you see this is x to the what power? Yeah, 7/5. And do you see this is fifth roots? Fifth roots 5 is a odd number, so fifth roots is continuous everywhere. The domain is everywhere, right? So on those 2 pieces, the function is continuous. So we only need to check when those 2 pieces meet. Okay, let's see. They meet at -1, right? So we compute limit x goes to -1 from the right, f of x. And we compute the limit x goes to -1 from the left, f of x. Again, remember, please write down your limits every step. Otherwise, you lose 1 point. Yes. Okay, let's see. Okay, so this is limits x goes to -1 from the right. And x goes to -1 from the right, it means x is greater than -1 or less than -1. Greater than. Then which formula do we use? The top one or the bottom one? The bottom one, yes. So we have a times, this is x to the 7/5 plus b. And we plug in x is -1. What's -1 to the 7th? -1. And the fifth root of -1 is also -1, right? So we have a times -1 plus b. So this is what we get. Right, everybody? So this is -a plus b. All right, on the other hand, we have limits x goes to -1 from the left. Which formula do we use? The top one or the bottom one? The top one, right? Oh, attendance. Yes, the top one. So we write down the top one. We have 3x e to the 2 times x plus 1 plus 4 minus 2a. So far, so good, everybody? We plug in x is -1. So we get 3 times x. X is -1. And then e to the 2 times x is -1. Do you see -1 plus 1 is 0? Yes, everybody? Plus 4 minus 2a. So far, so good, everybody? What is e to the 0? 1. Oh, we get -3 plus 4 minus 2a. What is that? Hey, Garrett, we need you to save us. Okay, thank you so much. Yeah, we don't. Function is continuous. 3 things. First, the function is defined, right? Second, the limits exist. That means the left side limit equals to the right side limits. And then the third one, the limits value equals to the function value at that point. So remember I said you have to say f of that number -1. Okay, where do we put the f of -1? Which formula do you see the equal sign? The top one or the bottom one? The top one. Oh, which is the 1 minus 2a. So we set this equals to f of -1. Right? Now we're ready. We can set them equal. So we have -a plus b. Set this equals to 1 minus 2a. Do you see you get equation with 2 variables, a and b, right? And when we see equation with 2 variables, we like to move the variables to the left-hand side, right? So let's move the a to the left-hand side. So we add 2b on both sides. Yeah. And then on your left-hand side, do you see 2a minus a is a? So we get a plus b equals 1. Right, everybody? So we get a plus b equals to 1. We get equation with 2 unknown. It's okay, that is possible. So we just say if a plus b equals to 1, then f is continuous. So this is part A. Okay. Unlike example 5. Yeah, example 5, we did that on Friday. Okay, let's go up to example 5. You can also see a note. Do you remember like the part A of example 5? We got b equals 5b minus 3. Then we can solve for b. Remember at that time we can solve for b? But that is because the a disappeared. That's why we get an equation with only one variable, we can solve for it. But in this case, because the a is still here, so we get one equation with 2 unknown. That's okay, just leave it there. Okay? And then continue. Part B. We want to find what values of a and b is. Oh, thank you so much. You are our heroes. Oh, is this yours? Oh, yes. Okay. Thank you. Bye. See you tomorrow. See you tomorrow. Thank you. Yeah, perfect. Yay! Thank you. Okay, so yeah, part B, we want to find the values a and b such that the function is differentiable. Okay, differentiable. We're talking about the derivative, right? So we make sure the right side derivative, we want to make sure it equals to the left side derivative. Is that okay, everybody? All right, the right side derivative. Okay, the right side is the bottom formula, right, everybody? So it's like the formula. So you can look at the part A. Is this formula what you need to take the derivative? So let's write it down. This formula, A times x to the 7/5 plus b. We want to take the derivative. And on the other hand, let's also write this down. So we just copy this thing, 3x e to the 2 times x plus 1 plus 4 minus 2a, and we take the derivative. Okay, so part A is about the function. Part B is about the derivative. Is that okay, everybody? Alright, now we already set up the part B. Let's calculate. Okay, what is the derivative? So remember, the variable is x. A and b are the unknown. It's like a constant, okay, a parameter. Okay, what is the derivative of a times x to the 7/5? Brain? Yeah, very good. B is the constant. Yeah, exactly. So x is the variable. Okay, x is the variable. And a and b, they're just constants. Okay? Alright. Okay, so we continue. Look at the second part. Right? We want to differentiate. Ooh, do you see this is something times something? A product, right? So what is product rule? Will? Yes. U is 3x prime v e to the 2 times x plus 1 plus u 3x v prime, so e to the 2 times x plus 1 prime. And how about the derivative of 4 minus 2a? A is a constant. Derivative of a constant is 0. Yes. So A and B are constant. It has no difference than like 5 or 10, a number. It's just a number. So as long as this is a number, the derivative is 0. No matter how complicated it looks like. Okay, so we continue. We have limits. So carry the limits all the time. What's the derivative of 3x? Dylan? 3, yes. And then e to the 2 times x plus 1. Okay? Plus 3x. Again, how about the derivative of this? Yes, very good. This is chain rule, right, everybody? So this is like our u. The derivative of e to the u is e to the u times u prime. So your u prime, this is like 2x plus 2. Your u prime is 2. Is that okay, everybody? So e to the 2x plus 1 times u prime, and the u prime is 2. Good. We get the derivative. Okay. Oh, and then let's go back to the first one. Sorry, we haven't finished. See? We still have the x. We should plug in x's -1, right? Oh, but -1 squared is 1, right, everybody? So up there, when we plug in -1, we just get 7 over 5a. Right, everybody? And then on the second part, we plug in x1. We get 3 times e to the 0. Yes. And then we get plus 3 times x is -1. And also e to the 0 times 2. What's e to the 0 again? 1. Oh, 3 times 1 is 3. Minus 3 times 2 times 1, 6. What's the answer? -3. Okay, everybody? So we set them equal. Okay. So far, so good, everybody? Alright, therefore, 7 over 5a is -3. And then we plug in, let's see, we solve for a, right? We both sides, what? Multiplied by the reciprocal. So 5 over 7, right? Then we have a equals what? Yeah, -15 over 7. We haven't finished. Because a function is differentiable, first of all, it must be continuous first. Right, everybody? Okay, so therefore, the a and b also satisfy a plus b equals 1. So you get your a, and because a plus b equals 1, your b is 1 minus a, right? We both sides subtract a, and that is 1 minus a is -15 over 7. Huh? A and B? A plus B is 1. Why do we what? Oh, you need to find the values of A and B. So you know A, but you also need to know B. So is C okay for all the numbers, or is C must be satisfied some condition? And a function is differentiable. First of all, it must be continuous. Do you remember that theorem? Differentiable implies continuous. Not continuous implies not differentiable. Therefore, the non-differentiable examples, you have 3 cases. The first one is when you have a corner. If you have a corner, then your left side derivative and the right side derivative do not match, right? And the second one is when you have a non-continuous. So you can have removable discontinuity, jump discontinuity, or infinite discontinuity, or essential discontinuity, right? And then the third case is when you have a vertical tangent. Because vertical tangent line, your solve does not exist. So those 3 cases, you have non-differentiable. Okay, so to be differentiable, it must be continuous first. And you can go further to talk about what conditions required to make it differentiable. Is that okay, everybody? So that's why we must satisfy the part A condition. So you can use it to find B. Therefore, we get 1 plus 7 and 15. The common denominator is like 7. How about your numerator, Paige? What's 1 plus 15 over 7? Huh? Common denominator is 7. So 1 is like you multiply by 7 and you divide it by 7. Yes. So 7 plus 15 is 22 over 7. Yes. Good. So we have found that if A is negative 15 over 7 and B is 22 over 7, then the function is differentiable. So far, so good, everybody? Okay, so we finished this example. I also want to show you the note with answers. So, okay, this is 5.3, the note with answers. And this one, this is when I prepare for the notes. Do you see I have mistakes? The derivative of b should be 0. So I had a mistake in the notes with answers. Okay, everybody? But I want to show you if you end up getting the equation with 2 unknowns, and then you couple with the equation with 2 unknowns from part A, do you get a system of 2 equations and 2 unknowns? Okay, everybody? So everybody look at me, because in the exam, your problem might be harder, so you might not get an equation with only 1 unknown so you can solve for it. You might get 2 equations with 2 unknowns. And then how do you solve the system? Do you still remember 2 method, either substitution method or elimination method? You compare the coefficients. Oh, it looks like the coefficients of B are both 1, right? So you can use one of them to subtract the other one. Then you can eliminate the B. You get equation about the A. You can solve for A and then plug in to solve for B. This is what happens when you have system of 2 equations, 2 unknowns. Okay. Sometimes if you like the coefficients are not the same, you find the least common multiple, right? You both multiply the equation by a number so that the coefficients match, and then you can subtract the 2 equations to eliminate that row. Is that okay, everybody? Yes. Okay, good. So we finished 5.3. Let's finally start 6.1. Okay. Let me make sure recording. Okay, good. All right, so 6.1. So chapter 6, by the way, your exam 3 just cover 5.1 up to 5.3. Okay, so we have finished the topic that we covered on your exam 3. Okay, so 6.1 and 6.2 is about applications. So chapter 5, we talk about how to find global maximum or absolute maximum and absolute minimum, right? And we can also find local max and local mean. And we can also find interval of increasing, decreasing. And we also talk about the concavity. If the second derivative is positive, then the function concaves up. Concaves up like a bow, right? That's concave up. Concave down is like an umbrella, remember? So you can sketch the graph of a function. By doing the first derivative, find the critical points, and do the second derivative, find the possible infraction points, and draw the giant table. Do you still remember? And then we also just talk about the problems like find the values a and b such that the function is continuous and differentiable. So chapter 6 is about applications. What can we do with these maximum, minimum? Okay, so big idea. Optimizing a quantity means finding the extrema of that quantity, which implies finding where the first derivative of the functions describing the quantity equal to 0. Big skills. You should be able to write a function that describes a real-world situation, and then find the extrema of that function and make sure the extrema are within a reasonable range of the physical values. For example, no negative volumes. Your area and your volume must be positive, and your time must be positive. You cannot go back, right? Okay, so we want to find the maximum and minimum. So for many real-world problems, let's talk about cost. You want to minimize the cost, right? Okay, you want to make something, you want to minimize the cost. Or if you have a fixed cost, let's say you want to build a fence, so you can raise some ship or lamp inside the region. Okay, you want to build a rectangular garden or regions, so you have the fence, but you only have like 200 feet materials. You want to build a fence, so you want to get what's the maximum area with the limited materials. Okay, so all these are optimization problems. So here we have some steps. Step 1, identify what we are looking for. What is the unknown quantity to be optimized? So you also want to sketch the picture. Okay, sketch the picture. And what shape are you talking about? Is it a rectangle or is it like a cylinder shape? Or so sketch the picture. And you also want to name the variables. Okay? And ask yourself, what is constant? And what is changing? If it's a constant, just give it that number. Okay? If it's a constant, it does not change, then don't set a variable. Variable varies. Okay? If that quantity is fixed, just put the number there. Don't name a variable. And then for the quantity that is changing, yeah, we name the variable. Usually for horizontal distance, we use x. For vertical distance, we use y. And A for area, V for volume. Is that okay, everybody? If you have circle, we talk about radius. Okay? If you have cylinder, then we have h is the height. Okay, everybody? So that's step 1. I would say, that's also step 2. Draw the picture, label the part that may be important to the problem. Set the variables. Okay, so yeah, step 2. And step 3, list the relations. We want to write an equation for the unknown quantity. Okay, for the unknown quantity. And express the unknown quantity as a function of a single variable. Okay, so that unknown quantity is what to be optimized. Okay, whether it's a cost or you want to like minimize the cost or you want to maximize the area or volume. Okay, so that is the unknown quantity you want to be optimized. Because we talk about how to find maximum and minimum, so you want to take the derivative of this unknown quantity, But we only learned one variable calculus. We haven't learned multi-variable calculus. That's why you can only take the derivative of a function with one variable. So you want to express this unknown quantity as a function of a single variable. Okay? And then step 5, you can differentiate a function and you can find the critical points, and then you can use the first derivative test to figure out this is a maximum or minimum. Okay, everybody? So we have 5 steps. Okay. Next, let's review some common shape. So for two-dimensional geometry figures, we have square. The area of square is s squared, right, everybody? Perimeter. Perimeter is, you have 4 sides, so 4 times s. Is that okay, everybody? How about rectangle? Rectangle area is length times width. Yes, everybody? Perimeter, we have 2 lengths plus 2 width. Yes, everybody? Okay, next one. I want you to look at parallelogram. So parallelogram, look at this piece. Okay, use a scissor to cut out this piece and then put it here. Do you see after you cut out this piece and you put it here, do you see you get a rectangle? Therefore, the area of a rectangle is base times height. Therefore, the base is A, right? And then times height. So parallelogram. Oh, okay, typo here. So base, yeah, usually we call the base is B. So here, let's put A, okay? So our base is A. So it's A times H. And the perimeter is 2A plus 2B. So far, so good, everybody? Next, triangle. Do you see if I get another copy of triangle and I put it upside down, I get a parallelogram? So the area of a triangle is half of the area of the parallelogram. And the parallelogram is at base times height. Okay, now I have to beat it. So this is correct. Okay, so perimeter, A plus B plus C, the sum of all the sides. And then let's look at trapezoid. Trapezoid. Let's also get another copy of the trapezoid and then you put it upside down. Do you see you get a parallelogram? Mm-hmm. So the area of the trapezoid is 1/2 of the area of the parallelogram. But your area of the parallelogram, this is small b, this is capital B. Do you see your new parallelogram, your base is capital B plus small b, and your height is h. Okay, this is how we get the area of the trapezoid. Okay, so yeah, it looks like a lot of formula, but if you understand it, it's not that bad, right? You start with the square and then rectangle, and then a parallelogram, and then triangle is half of the parallelogram. Trapezoid is also half of a parallelogram. Okay, so all of those things are connected. Okay, and then sum of the perimeter is just the sum of those 4 sides. Okay, last one, circle. Do you all know the area is pi r squared? Circumference. Interesting. Why don't we call it perimeter? Why do we call it circumference? So circle is special, right? So circumference 2 pi r is also equals to pi d, where d is the diameter of the circle. Right, everybody? Okay, how about 3D? So 3-dimensional figures. We have volume volume and surface area. Okay, volume for cube. Oh, S cube. Right, everybody? How many sides the cube has? Six. Right, you wrote that. You have six faces, right? So 6 times each face is a square. So S squared. That's the surface area. Rectangular solids, volume. So for all the cylinders, okay, for all the cylinders, your volume is always area base times height. Your rectangle is like a cylinder, but your base is the rectangle. Do you agree, everybody? Mm-hmm. So area base is length times width, and then times height. That's why we get this formula. Surface area. Do you see we have the front and back, two sides, and then the left and right, and the top and the bottom? All of them are rectangles. So top and bottom, the area is length times width. So 2 times length times width, top and bottom. Left and right, sorry, front and back, length times height. Okay, so 2 copy of that. And left and right is width times height. Right, everybody? So 6 faces of the rectangular solids. And right circular cylinder, this is the right circular cylinder, is area base times height. And then our area base is pi r squared. Okay, everybody? And then times height. Surface area. Do you see you have top circle and the bottom circle? So you have 2 copies of the area of a circle. So you have the top and the bottom. So you get 2 pi r squared. And then the side, do you see if you have a scissor and then you cut it and open it, you get a rectangle. Can you imagine you open it, get a rectangle, and your width is the height, your length is the circumference of the circle, which is 2 pi r. Therefore, the area of this rectangle is 2 pi r times h. Is that okay, everybody? Mm-hmm. So draw the shape and then cut it, open it, then you can calculate the surface area. Okay? Cone. For cone, the volume is 1/3 of the volume of a cylinder. Okay, so for the cone, the volume is 1/3 of the cylinder. Okay, why this is 1/3? So when we go to applied cap 2, we can talk about that why. Okay, so this is 1/3. Okay, and sphere, volume. Oh, this one you gotta memorize. Volume is 4/3 pi r cubed. Okay, 4/3 pi r cubed. Okay, and then the surface area. Okay, so how do you remember the surface area? You can think about when you take the derivative of this. Do you see when you take the derivative, r is the variable, pi is a constant? Well, when you take the derivative of r cubed is 3r squared. With 3 and 3 cancel, you get 4 pi r squared. So I figure out the surface area and the volume has this relation. So you only need to memorize the volume. And then the surface area, you can just take the derivative of this, then you get the surface area. Okay, everybody? Mm-hmm. So those are all the important shapes. And now let's look at examples. Okay. So I, Suki, wants to make an open top rectangular box with a bottom and 4 sides, but no top, out of a piece of paper that is 8 by 10 inches. So I have a paper that is 8 by 10 inch. And I cut out 4 equal size squares. So I cut out 4 equal size squares from the corners. And then I bend up the sides. Do you see when I bend up the sides, I get a box. And it's an open top box. Can you imagine, everybody? So I get a piece of paper, I cut a corner, and then I can bend it. I get a box. Right, everybody? Okay. What size of the square? Okay, this is the square. What size of square should I cut out to maximize the volume of the box? Okay, let's see. This is X. Okay, it's a square, so all this size is X. Is that okay, everybody? We want to find the X so that we can maximize the volume of the box. So our goal is to maximize the volume of the box. Okay, so we want to relate the box, the volume of the box, and okay, let's see. Do you see the width is actually 8 minus what? Minus 2x, right? It's 8, and you minus 2x. That's the width. See? The width is 8 minus 2x. So this is 8 minus 2x. How about your height? Oh, yeah, sorry. Your length. What's your length? Yeah, so 10 minus 2x is the length. How about your height? X. Exactly. Right, everybody? This is our box. And the width is 8 minus 2x. The length is 10 minus 2x. And my height is x. So I want to maximize the volume. Okay, my volume is length times width times height. My length is 10 minus 2x. My width is 8 minus 2x. My height is x. So far, so good, everybody? See, we have the volume is a function of a single variable. So far, so good? So we can take the derivative. But I don't like product rule. Do you like product rule? Yeah, so we can distribute, expand it. So you only get a polynomial. Then when you take the derivative, you only need to do the power rule. You don't need to do product rule. Okay, so let's distribute. Okay, what is 10 times 8? 80. 10 times negative 2x? Negative 20x. Negative 2x times 8? Yeah, negative 16x. Negative 2x times negative 2x? 4x squared. And we multiply by x. Right, everybody? So combine the like terms. How many x? Negative 36x plus 4x squared. We multiply by x. Do you see we get 80 minus 80x minus 36x squared plus 4x cubed? Yes, everybody? Let's reorder it. Usually we like to see the highest power go first, then the lower powers. Okay, so this is the volume, and it's a function of x. Okay, we want to maximize it, so we want to take the derivative of this. Okay, and we ran out of time. Let's continue on Wednesday. Okay, have a nice day, and don't forget today you have homework 6. It's due today. And this Friday, you have homework 7 and quiz 4. Okay? And also I give you back your exam, so please do the exam correction and exam record. Our exam 3. Oh, exam 3. Yeah, exam 3 is next Wednesday. Okay. Have a nice day. And if you have questions, please come to ask me. Your homework, you can do it multiple times, again and again. Bye.